So, if you have $270 to spend on tech today, you could buy a decent smartwatch.
Right. Or like a really nice pair of noise-canceling headphones.
Exactly. Or you could buy a single 25-foot cord. Welcome to the deep dive, everyone.
Yeah, it sounds a little crazy when you put it like that.
It really does. But today, our mission is to figure out why this one piece of copper wire, specifically the DVIGear DVI-2307-HRD Dual-Link DVI copper cable, why it commands that kind of price tag.
Sure.
So, okay, let's unpack this. Because to most of us, a cable is just, a cable. You plug it in and it works.
Oh, for sure. It is definitely a massive case of sticker shock. But I mean, what's fascinating here is just the sheer volume of data this specific cable is engineered to carry over a pretty long physical distance.
Yeah, 25 feet is no joke for data.
Not at all. We are talking about supporting ultra-high PC resolutions up to 3840 by 2400 at 60 hertz. It's pushing an aggregate maximum of 4.95 gigabits of data per second.
Wait. Almost 5 gigabits a second. That is a staggering amount of visual information moving continuously.
Exactly. And over 7.5 meters.
I have to admit, I've always been a little confused by this because a digital signal is just ones and zeros, right? It's not like an old VHS tape where the picture gets all fuzzy.
Yeah, that's a really common misconception.
Right, so I just think, wouldn't it just arise? But it's kind of like trying to shoot a high-pressure fire hose of water perfectly across a 24-foot room without spilling a single drop, right? How does the cable actually achieve this without degrading the signal?
I actually love that fire hose analogy because those ones and zeros are still, at the end of the day, physical electrical pulses traveling down a wire. And electrical pulses face resistance.
Right, just like friction in a hose.
Exactly. The longer the wire, the more the signal weakens and fades out. In engineering, that's called insertion loss. So to combat that over nearly 25 feet, this cable uses really heavy-duty 26 AWG copper wires.
Okay, so a thicker wire gauge gives the electrical pulses a wider, clearer path.
Right. It maintains the strength of the signal from point A to point B.
But over that distance, doesn't a 25-foot copper wire basically act like a giant antenna? Like, it seems like it would pick up every bit of stray electromagnetic noise in the building.
Oh, it absolutely would. And that is where the triple shielding comes in. The cable is wrapped in multiple dense layers of insulation.
It's just to block outside electrical interference from, corrupting your data stream.
Yeah, exactly. And then at the ends, you have these gold flash-plated connectors, because gold doesn't oxidize or rust over time like other metals might.
Which ensures those microscopic contact points stay perfectly conductive, right? Even decades later.
Spot on. But we also have to remember a dual-link cable is carrying multiple lanes of data at once. You are fighting two massive enemies of digital video here, which are jitter and skew.
Skew. What does that actually mean in this context?
So if one of those internal copper lanes is poorly manufactured, say it's even a fraction of a millimeter longer than the others, the data traveling down that specific lane takes longer to arrive.
Oh, wow, so they literally get out of sync.
Exactly. If those data packets arrive out of step, your monitor drops pixels or just glitches out entirely. The precision manufacturing of this cable guarantees unsurpassed digital fidelity, meaning every single microscopic pulse arrives perfectly aligned.
Okay, I get the engineering's impressive, but again, $270.
Yeah.
So what does this all mean for the person actually using it? Because even if a cheap cable glitches eventually, I can just buy a $10 replacement and swap it out on my desk.
Well, sure, you can swap a $10 cable on your desk, but you cannot easily swap a cable that is permanently buried behind drywall.
Ah, I see where this is going.
This is where those UL13, specifically the CL2 and UL758 ratings come in.
Okay, and in plain English, that means?
Those certifications mean this cord is legally rated, basically in-wall rated, to be snaked through the walls and ceilings of a commercial building.
So this really isn't meant for a home office. This is designed to be permanent, heavy-duty infrastructure where failure just isn't an option.
Think about a surgical operating room using medical imaging, or, a military control center, or a high-end broadcast studio.
Right, places where a signal dropout isn't just an annoyance, it's a total disaster.
Exactly. You can't afford to tear down a hospital wall to replace a cheap oxidized wire. When you buy this, you are paying for absolute guaranteed reliability over long distances.
It really is the invisible backbone of those systems. And just to round out our sources and add some final details, this cable is also RoHS compliant, meaning it's green friendly and free of certain hazardous materials.
Yeah, and it comes backed by a 3-year warranty, which is nice for that extra peace of mind.
Definitely. Well, this has been incredibly eye-opening.
It really has. And I'll leave you with this final thought to ponder. The next time you are in a critical environment, maybe a hospital, or you catch a glimpse of a security control room and you see a flawless, high-resolution digital display, ask yourself what kind of heavy-duty, unseen infrastructure is hiding inside the walls, making that seamless image possible.